technology opens up new horizons for the food industry. Technical innovations help to optimize production processes, increase efficiency, and improve food safety. DLG offers a network for experts in food technology and innovation. Its aim is to help producers provide high-quality food for a growing worldwide population more efficiently, more sustainably. The International Food Tech Award is the focal point of these initiatives. The award has been recognizing groundbreaking developments in innovation, sustainability and efficiency in the food tech sector since 1994. An international jury of experts from 7 countries has selected the most innovative concepts in the most important areas of food production. Today, we are proud to present the winners of the International Food Tech Award.
Good day and welcome, ladies and gentlemen. In 2021, the International Food Tech Award will demonstrate once again impressively what concentrated innovative energy lies in the global food industry and its supplier companies. DLG, in cooperation with strong trade and media partners, is presenting the prestigious Technology Award for the 11th time this year. This is unquestionably only possible because the spirit of progress and inventiveness coupled with the engineering of the highest quality repeatedly show themselves capable of overcoming technological hurdles and developing new potential for sustainability and efficiency. DLG is fundamentally committed to increasing professional expertise with its network of experts and ensuring a broad-based transfer of technology and know-how into the business practice. In this context, the International Food Tech Award highlights the top-class research and development achievements of the food industry and serves as both an incentive for and recognition of the sector. Altogether, 20 innovation projects from the international food industry and its suppliers will be presented with awards for groundbreaking developments in food technology this year. 5 innovations will receive the International Food Tech Award in gold, and 15 innovations will receive the award in silver. Among the award winners are companies from Australia, Spain, Italy, Switzerland, and Germany. In the name of all the award partners, we congratulate the winners of the International Food Tech Award for their successful implementation of pioneering innovations. And first of all, I would like to introduce now our keynote speaker. This is Professor Dr. Michael Gensler from the University of Alberta in Edmonton, Canada. Dr. Gensler received training in food engineering and food microbiology at the University of Hohenheim, Oregon State University, and the Technical University Munich, and is currently Professor and Canada Research Chair in food microbiology and probiotics at the University of Alberta in Edmonton in Canada. Generally, his research aims to link microbial physiology and ecology to food quality and host health. His research interests include the development of novel non-thermal technologies for food preservation, aiming to understand mechanisms of bacterial resistance to pathogen intervention technologies, and the functional characterization of lacid-active bacteria for use as starter cultures, or probiotics in foods and agricultural applications. Dr. Gensler serves also as associate editor of Frontiers in Microbiology and is member of the editorial board of Food Microbiology, Applied and Environmental Microbiology, and the International Journal of Food Microbiology. So he's a really, really well-known expert, and I'm looking really forward to his keynote lecture towards a safe, high quality and sustainable food supply, challenges and opportunities. The floor is yours. Thank you.
Thank you, Dr. Rehn, for the kind introduction. I want to thank the organizers to give me the opportunity to introduce this year's awardees for the 2021 International Food Tech Award. Without further ado, I want to briefly touch on the award. The award is for products which demonstrate a new concept or significant advance in a new concept, which are significant for industrial practice. The second half of the conditions means that there needs to be demonstration that innovations actually are useful for commercial food production. This year, a team of 13 jurors reviewed 73 submissions to give the 20 awards that Dr. Rehn just mentioned. And I think this is the place to acknowledge my colleagues in the jury for the very helpful discussions in the deliberations in 2 sessions. To find common themes among the submissions, I was making a word cloud with the descriptions of the award-winning submissions. If you look at this word cloud, more frequently used words are bigger. We see quality, packaging a little bit smaller, fresh and flexible. So apparently many of the innovations aim to get high quality food to the consumers and to ensure that they remain fresh throughout the storage life. A second theme, which is fairly obvious, is if you look here, the word costs, efficient, simple. So apparently cost reduction, energy reduction is a topic which is key for innovations in the food industry. A third theme, which is found in many applications, is safety. For example, here we see the word hygienic design, microbiological risk, contamination, safe. So preventing microbial contamination remains a key driver for innovation. Other pieces, I will get back to that later, for example, baking, which was also awarded in one case. Before looking forward, I want to look back. The requirement for demonstrating suitability for commercial application means most applications probably have a substantial development time. If we go back to innovations in food processing, the first processed foods, starting with the onset of our agriculture, were probably beer and bread. The cheese and wine to go with the bread came a couple of 1,000 years later. Innovation picked up substantially in the late 19th century after the Industrial Revolution, when pasteurization, refrigeration, and chemical preservation were used. And again, since the transition to the knowledge economy, approximately in the last 30 years, we have seen an accelerated pace of innovation with, for example, high pressure, hygienic design, and pulsar electric fields being introduced as novel concepts or processes in food production. How long does it take for a novel concept to be used in commercial food production? The discovery that yeasts are responsible for fermentation provides one example. Louis Pasteur published the yeast fermentation in 1857, and then it took approximately 10 years until the first baker's yeast factory opened in Vienna to use the concept for accelerated bread fermentation. A second example is the case of high hydrostatic pressure. Intensive research and pioneering food applications started at around 1990. It took approximately 10 years and a lot of engineering and a lot of scientific discovery before large-scale equipment became available. And in the last 20 years, the number of commercial installations has increased substantially. Nevertheless, improved equipment, for example, in-bulk treatment and high pressure, high temperature treatments to continue to support novel applications. One of them is among the awardees that will be presented later. A second one will be introduced shortly in Australia, where a high pressure preserved milk product will become available in the next weeks, which is significant because this is one of very few neutral pH food products which rely on high pressure treatment as the sole preservation technology. Which challenges lie ahead in the field of non-thermal processing? The pressure resistance of Bacillus endospores is a problem that has been, in principle, is understood from the research side. Some bacterial endospores, including Bacillus acinoliquefaciens and Clostridium botulinum, are pressure resistant, which means neither at ambient nor at high temperature does pressure accelerate spore inactivation significantly. And the efficacy of pressure-assisted thermosterilization has been demonstrated, but is not yet used commercially. To give you an indication of how resistant the spores are, here you see the reduction of spore counts after treatment for 3 minutes at 600 megapascal and 80 degrees centigrade. For some spores, these are all spores of Bacillus acinoliquefaciens or Bacillus subtilis. The reduction of spore counts is less than 1 log CFU per gram, which means a very minimal reduction of spore counts. Since 2 years, we start to understand how and why these spores are so resistant. A Dutch group discovered a genomic island, which was called the SPOV-A2 MOP operon, and the genes on this genomic island relate to spore formation and spore germination. If a genome of a Bacillus strain has multiple copies of this operon, they start to be highly pressure resistant. This doesn't accelerate their inactivation, but it allows us to understand or to detect pressure resistant organisms. And Salmonella. For example, since 2016, in North America, we had repeated outbreaks with Enterohemorrhagic E. coli in wheat flour to the point that the big mills start to consider decontaminating all of their products. The problem that we have here that Salmonella, Chronobacter, and EHEC, after drying, they're just about as heat and pressure resistant as bacterial endospores. So it's really difficult to decontaminate dry products. Current technologies which are under investigation are high pressure carbon dioxide, cold atmospheric plasma, light emitting diodes, or oxidizing chemicals. But in my view, it's too early to make the call which of these technologies will make commercial application. To switch gears a little bit, a success story in the last 15 to 20 years was the hygienic design of processing facilities and processing equipment to keep factories clean, which is a fairly essential component of a safe food supply. Here we continue to see interesting innovations. Here you see an image of a cicada. Cicadas have nano-sized structures on their wings, which have strong bactericidal properties. They physically impale bacteria which attach to the surface, and current efforts aim to engineer surfaces to make this effect accessible to commercial applications, also in the food industry. Despite significant advances, the problem persists. these are two figures which are taken from a recent publication from the Robert Koch Institute in Berlin. They analyzed 20 Listeria strains which were taken from an outbreak which related to a single meat processing plant in Germany, or plant isolates from that facility. Comparing the genomes demonstrated a very high degree of relatedness. So these Listeria genomes differed by less than 11 nucleotide substitutions, which possibly or even likely means that the same strain persisted in the processing facility for more than 5 years. How do bacteria persist at a certain place? They produce biofilms, which you can call cities of microbes. So this is the opportunity to show a picture in Edmonton, a picture of Edmonton, which also allows a city which allows persistence in rather adverse conditions because the mean temperature in February is approximately -7. To put things in perspective, on the left side, you see an image of the pyramids of Giza. They're 140 meters high, 200 meters across at the base, or in other words, they're approximately 100 times the size of the humans that built it. On the right side, you see an image of a schematic image of a bacterial biofilm. From the base to the top, these structures measure approximately 150 micrometers, which means they're 100 times the size of bacteria. So the word of cities of microbes is reasonably appropriate. In the case of biofilm formation, bigger is better, because the more thick the biofilm is, the more resistant the bacteria are. What you see here is a correlation of the biofilm thickness, which is measured by absorbance with a dye, which stains the biofilm matrix, and the resistance to chlorine. A high number means bacterial inactivation is strong. A low number means bacteria are very resistant. So you see a fairly good correlation of the biofilm thickness to resistance to chlorine, which means biofilm formation makes it difficult or impossible to eradicate contamination of food processing facilities and food processing surfaces. Also in the case of chlorine resistance, bacteria have additional mechanisms which increase their resistance. This is again a genomic island which is shared among strains of Escherichia coli and related Enterobacteriaceae. The genomic island has approximately 15,000 base pairs. If strains include this genomic island, they are fairly resistant to chlorine, hydrogen peroxide, and peroxyacetic acid, whereas isogenic strains here shown by the white bars, which do not encode for this genomic island, are much more sensitive. So this appears to be a tool, a bacterial tool to evade oxidative inorganic chemicals. Before we address the challenges and opportunities that lie ahead, let us recognize and celebrate the achievements of the winners of the International Food Tech Award in 2021. And keep in mind that innovation sometimes requires a look back into the history. One example is shown here. This graph depicts the use of the search word sourdough on Google in 2020. So apparently, in this case, innovation relates to the use of a very old technology with new processes. And with that, I want to thank the audience for listening and hand back to Dr. Rien. Thank you.
Thank you so much, Professor Gensler. I think it was a very enlightening and interesting keynote lecture for all of us. And now we want to switch to the presentation of the silver medal winners of this year. And we will start with a short video first.
DLG is happy to announce the silver medal winners of the International Food Tech Award 2021. The silver winners in the category All Food Industries are Albert Handmann Maschinenfabrik GmbH und Co. KG, Biberach, Germany, FS 525 all-in-one forming and cutting system. Perox GmbH, Dresden, Germany, self-learning assistance system for machine operators. Plasmion GmbH, Augsburg, Germany, Secret, innovative ionization technology for real-time analysis. Starback Systems GmbH, Kandern, Germany, Australia, Jupiter 445, high-speed vacuum packaging machine. Stahl GmbH, Stadtlohn, Germany, food distro wall. The silver winners in the category meat and sausages, poultry and fish are CSB System SE, Geilenkirchen, Germany, CSB Jumbo Flash, artificial intelligence for raw ham quality control. K+G Wetter GmbH, Biedenkopf-Breitenstein, Germany, vacuum industry, VCM 360 and VCM 550, hygienic secure. Mado GmbH, Dornhahn, Germany, finger protection system, FPS. Maschinenfabrik Seidelmann KG, Stuttgart, Germany, RFID cutting set. FEMAG Maschinenbau GmbH, Verden-Aller, Germany, FEMAG LL335, universal solution for the automatic grouping and packaging of fresh sausages in trays. Habasit International AG, Rheinach, Switzerland, the innovative Habasit Super High Clean Modular Belt. The silver winners in the category dairy products and baby food are GEA Westphalia Separator Group GmbH, Oelde, Germany, Ideal Waste Separation. Optima Consumer GmbH, Schwäbisch Hall, Germany, EGS, development of an innovative system for evacuating, gassing and seaming infant formula containers. And finally, the silver winners in the category beverages, vegetable and food processing are Krones AG, Neutraubling, Germany, aseptic dosing for minimum quantities. Tropical Food Machinery SRL, Bussetto Parma, Italy. Sarare 6000, the new TFM automatic banana peeler. Congratulations to all silver medalists.
The International Food Tech Award from DLG and its partners recognizes groundbreaking developments in innovation, sustainability, and efficiency in the food technology sector. An international panel of experts from research and academia, as well as representatives from field select the most innovative concepts. The prestigious Technology Award is presented by DLG every 3 years in the form of gold and silver medals. Silver medals are awarded to existing projects which have been developed to such an extent that a substantial improvement in their function and in the process is achieved. Let's say congratulations to all silver medal winners, and we will skip to the next category here. So we will present now the gold medal winners, and I would like to introduce the first gold medal winner, and the topic of this medal, or the prize they get for, is ohmic heating of meat and sausage projects. We would like to welcome Seidelmann Ohmic Systems here from Erlen in Germany. And I will talk to Mr. Andreas Seidelmann and Kevin Eberhard.
Hello.
Hello, welcome and nice to see you.
Thank you very much.
Thank you so much for being with us. Let me introduce, I have a few questions. Ohmic heating of meat and sausage products is a heat treatment process. When electric current is passed through it, the ohmic resistance in the food causes to heat it up. And the sausage meat or piece of meat serves like a conductor between these two electrodes. Can you tell us a little bit about the advantages of ohmic heating?
Yes, sure. The advantages of ohmic heating are volumetric heating of the product without use hot surfaces, depending on the conductivity of individual product fractions, as well the configuration of treatment unit and the flow properties of the food. Heating takes place with low temperature gradients. Heating times can do significantly shortened so that the cooking load of the food and thus process-related change quality can be reduced. Since no hard surfaces are used, higher product quality and less deposition of unreversible layers of biological, organic, and inorganic composition can be accepted if the electrode configured suitable designed.
Thank you so much, Kevin. And maybe this leads us also a little bit to our next question. What is the technological advance of your solution compared to conventional cooking equipment?
The heating takes place uniformly over the entry length across the section, the shortest possible time. In addition to energy savings over 80%, considerable time savings, this results in a continuous process with a fraction of space requirement of conventional cooking facility.
Talking about energy, what are the energy requirements of the machine?
Depends, for sure, it depends on the product, but when you're producing 15 tons of cooked ham per day, the machine has paid it for itself after 1.5 years, just considering the lower energy costs. That's a super ROI. The savings are the energy costs. Ohmic electric costs are 2 cents per kilogram of product compared to 4 or 6 cents of a product for conventional steam production in cooking chambers.
Wow, that's really impressive. And how does ohmic heating on the other side improves also the product quality?
It's very good for the product quality because the step heating curve minimizes microbiology risks, and the shorting heating time preserves flavors better, quite better. In addition, there's a less cooking loss, jelly formation is reduced, and there are no overcooked or dry edge stripes.
Wow, that sounds really promising. Fat, for example, has a lower conductivity. To what extent does this method work for inhomogeneous pieces of meat with a high fat content or like fat inclusions? Like can locally low temperatures occur with an insufficient to kill microorganisms and therefore endanger the microbiological safety of the product?
Despite the mentioned process advantages, different electrical conductives of individual product fractions or uneven distribution of the electric field also lead to inhomogeneous in heating with this process. Depending on the product and process parameters, the occurrent locally high as well locally low temperature must therefore be taken into account during process evaluation.
Thank you so much for your explanations, Kevin. I think it was very, very enlightening for us all to hear about that. Congratulations again to both of you. I think it is really, really a great step forward. And yeah, congrats.
Yes, thank you. Me and the whole team from Sios and Seidelmann, we are very proud and thankful. Also, congratulations from our side to all the other gold and silver medal winners. If there are any question, more detail, don't hesitate to contact us, and looking forward to see you personally on the next exhibition, we hope. So thank you for attention. Stay safe.
We cross our fingers for that. Thank you so much.
Bye-bye.
Take care. Thank you.
Okay, and now we will just switch over to the next gold medal winner. And the topic of this gold medal is multi-variable baking process, an oven with a combined heat transfer. And this oven is from Kuchenmeister. The Kuchenmeister GmbH is located in Soest in Germany. And today I will talk to Mr. Hans-Jürgen Trockels, the Managing Director, Ms. Maike Lauterjung and Mr. Rüdiger Young from Management, Research and Development. Welcome to all of you. This is just Mr. Young. Good to see you. And I hope you can answer us some questions about this innovation. Like, what does the technical creativity and quality of your solution consist of?
With the development and use of the process, it is possible for the first time to vary not only the temperature, but also the type of heat transfer during the baking process. As a result, process and quality parameters such baking loss, pastry volume, and crust thickness can be adjusted. There are two frequency controlled fans in each segment, which regulate the intensity of the heat transfer. The air flows through nozzles evenly distributed into the baking chamber. The flow speed is freely selectable. Independent of the convection, the intensity of the radiation is controlled by the temperature and flow rate of the thermal oil.
Okay, thank you so much for explaining that to us. So we know a little bit about the technical innovation now, but what are the particular technological benefits of your solution in industrial applications?
As for each type of pastry, there's an ideal heat transfer during the baking process. Small baked goods are effectively produced with convection ovens. Heavy baked goods are usually baked with radiant heat. It is also possible to change in every segment the intensity of radiation and our convection. And by 100 quarter meter oven, can we do it 12 until 15 times. All types of baked goods and long life baked goods can be produced with the oven with combined heat transfer. The technological benefit lies in the great variability achieved by the parallel or separate, mutually independent application of convection and radiation. This achieves a uniform optimum baking result.
So you can say it is applicable to all kind of baking goods, and this is really, really impressive. But let's also talk about like economics. What are the economic benefits of using your solution?
The benefit lies in the optimal baked product quality. In the energy savings of 10 to 20% minimum. I think it's dependent from the kind of pastry, it is maybe also more. But our first experience with the first oven from company Confile is show that we have that we can spend around about 20% of energy.
That's really, really impressive to hear that.
And the next benefit is the variable using of the oven. Okay,
so you can use it in a broad range of applications and save energy at the same time. I think that's a really, really, really great benefit on all topics. So thank you very much for this nice presentation, Mr. Young. I would like to say congrats again to this gold medal. I think it's you really deserve that because it's such an innovative product. So congrats to all of you and your team. Thank you very much.
Thank you.
So we will just jump over to the next gold medal winner here. And This gold medal is for the butter packaging with a freshness seal. And the winner of this gold medal is the Alpma Alpenland Maschinenbau GmbH from Rotterdam here in Germany. And I will talk today to Mr. Gisbert Strohn. He's the managing director, and to Franz Glas, the management cutting and packaging technology. And yeah, I think almost all over the world, butter is traditionally simply wrapped just in foil. What are the main advantages of Alpma fresh packaging compared to the conventional wrapping of butter?
Yeah, thank you very much. First of all, welcome from Rotterdam Inn. It's close to Munich, and thank you so much for this great award. It's really an honor for the company Alpma, but especially for the team from Franz Glas, who made so many efforts to make it happen. And I would like to show you short by 2-3 slides how it works, and you will understand easily where the big advantages are. So we would switch to a short slide presentation. Okay, hope you can see that. We started to make this packaging for butter just from zero. That means just with an idea in our mind and having a clear goal in front of us, like a vision. So we could move to make a new butter packaging with really unique key figures, which is very close to a lot of products what you are used to buy every day. You can see that there are really significant developments over the last decades for so many products, but nothing for butter. Since the last 50 years, nothing happened with the traditional, you called it fold wrapping butter packaging style, and it was really time to make something new. Let's have a look to the key figures. The key figures of this packaging is keeping the normal style of a butter packaging, but the most important point is the safeness to keep the aroma protection. How does it work? It's a sealed packaging. That means we are closing the packaging and avoid the contact to the oxygen exchange, which keeps aroma like a very fresh butter internally. The second advantage is very close to this. That means we have a much longer shelf lifetime. This is approx 50% longer compared with the old format traditional fold wrapping packaging. And nevertheless, one of the targets for this packaging, everybody knows that opening a butter packaging is not that easy. You will always have fatty fingers, and a lot of times, you know, later on you don't like that. That means you have to have a feature with an easy opening, having the opportunity without any tool to open this sealing. And this is another big advantage. You can see the force is a tamper evident closure. You look for so many products which are really safe for the consumer, and you can see whether it has been opened before or not. The butter so far, no opportunity. The new style, you can see that it's really tamper evident close. And there are some more key figures we would like to combine with the next question I would like to ask you for, and Mr. Franz Glas will guide you through.
Thanks. Yeah, the other advantages is the premium image. With this packaging, you have a very good image in the point of sale, and for the consumer, this is recognizable as a butter pack. We are waiting for the next question.
Okay. I just didn't want to interrupt you. So no more greasy fingers and protection for the product. It is a sustainable design, and the reduction of packaging is on the same time an important issue. How environmentally friendly is Alpma fresh packaging if you compare it to others?
Yes. In terms of environmental sustainability, the Alpma Fresh Pack has many advantages. The product is very well protected, as Mr. Strohn have mentioned before. This is quite comparable to packing in a plastic cup. However, as you can see in this picture, it is a film packaging or not a plastic packaging or a carton. For an optimal product protection, it requires much less packaging material compared to the plastic cup. For example, based on a 250-gram butter pack, the packaging weight of a plastic cup with lid is approximately 15 grams. The packaging weight of the Alpma Fresh Pack is only about 2.5 grams. That means less than 20% packaging weight. And the Alpma Fresh Pack is also suitable for packing mixed spreads or margarine. These products are almost exclusively packed in plastic cups today. And also a big advantage is compared to the conventional butter film packaging, the product stays fresh longer. This brings advantages for the retailers because of the extended shelf life and avoids the destruction of food. A very important argument regarding the sustainability.
Thank you so much for explaining that to us. I think that's quite impressive, but we have heard about lots of advantages. Are there also restrictions? And what restrictions does someone have to reckon with if they want to purchase a new packaging machine for fresh produce packaging?
Only small restrictions, clearly. Because of the additional sealing and folding functions, the machine for producing the fresh pack is longer and bigger as the conventional butter packaging machines. This usually requires adjustments, changes, modifications to the line setup. But for the medium output range, however, it will be possible to pack the same packaging style with a compact rotary version. This space requirement of this machine, the rotary version machine, is almost comparable to that of the conventional packaging machines for butter.
So space is not in any case a limiting factor here, as I understand that. Have you already installed the machine? And if so, in which performance range does this machine work?
Oh yes, we have indeed already installed a line. It's not a theoretical development what we are presenting here. The line is now in operation. It's exactly the machine like in the picture behind us, a running through machine since almost 12 months in full operation. Very satisfied producing and fulfilling the spec what we offered there. The speed is a high speed, high performance system, which around 200 packs per minute of 250 grams butter style. And nevertheless, like Mr. Glass pointed it out, there are varieties in case of capacity which are now in production, so we will have different steps of capacity in the future.
Thank you so much. That's really, really impressive. And congrats again to Mr. Glass and Mr. Schrum for your gold medal. I think it's really, really impressive what you demonstrated us here. And thank you very much for that. Thank you.
Thank you so much. And also our congratulations to all the other winners. And thanks again. Stay safe.
Safe. Thank you very much.
Thank you.
So, and we will welcome now the next gold medal winner. And I would like to welcome from Spain, Dr. Carol Tonello, Applications Director at Hyperbaric. And she developed, or her team and her company developed the Hyperbaric HPP in bulk technology. The company is located in Burgos in Spain, and I'm very happy to welcome her here. Carol, how does your solution rate in terms of technological creativity and quality?
Thank you for the nice introduction. to our technology. Well, and of course, we are all, the Hyperwerk team is very grateful because this is an honor for us to receive this this Food Technology, International Food Technology Awards, and to share the gold medal with the other company here, with impressive also developments concerning the technology. And I also wanted to say to Professor Gansel that the presentation was really good, really interesting. Thank you very much. So in terms of technological creativity, our Hypersure machine, Hypersure processing machine, is really a unique solution and a global innovation. This is the only Hypersure processing equipment that allows to process liquids in bulk. Other technology are Hypersure processing HPP in pack. This means that the product is previously packed before it's processed in a chamber with Hypersure water surrounding the product. We have changed with the bulk technology. We have changed this way of processing. This machine is the result of a R&D project that was funded by the European Commission with an SM instrument, call. So it has been a 4-year development for our company. So this is what we've done, is that we have developed a technology more predictive, saving energy, more cost effective, and one of the main benefits also is that it's very versatile because we can use any type of packaging. The HPP impact technology, the classical one, which exists for now 30 years at the industrial level, is restricted to flexible packaging, which is plastic packaging, and this is not always what the producer or the consumer wants. So with this bulk technology, the liquids, the juice, the beverages are processed directly in the machine in bulk, and then it goes to a tank. And from this tank, you can pack the product in glass, in carton, of course, also if you want in polyethylene or PET bottle. So in terms of quality, I would say this is exactly the same very high quality of Hypersure processing. So it increased the shelf life of the juices by up to, I would say, up to 30 times. So we go from a few days to a few weeks or a few months, depending the product. So it extends the shelf life, and we keep a fresh flavor, odor concerning the juices or the smoothies we can process. So with the bulk technology and with the impact, this is exactly the same quality, the same efficiency concerning shelf life, inactivating pathogen, and in keeping the fresh attributes of the juice.
Yeah, thank you so much. I think this is really impressive. But on the other hand, we are always talking also about economy. What are the economic benefits of using your solution, Carol?
Okay, so this solution is conceived for large juice production, which is in our case a maximum of 5,000 liters per hour. The largest production with an impact machine is the 3,500 liters per hour. So we increase the productivity by almost 40%. I would say only increasing by 20% the investment costs. But really the benefit also can be seen in the labor, this is a fully automatic solution. It means that we save 80% of the labor costs, and also we save roughly 50% of the energy per liter of juice or beverage process. So roughly we save per liter of juice or beverage processed, we are at 45% less than the same process in impact machine. So economically, I would say, I mean, our idea with this project was to offer to the market a greener technology and more affordable technology for large beverage production. And we have one machine in production nearby Paris, producing juices. So, as our previous previous award company said, that this is not only in the picture, this side, sorry, this is a real development, a real innovation. Thank you very much again, and congratulations to all the silver and gold awarded companies.
Thank you, Carol. Congratulations to you. I think it's really, really innovative, and I think you presented it very, very well to us. Thank you for that. And this leads me to the next gold medal winner. It is the Allgeier process technology in Uingen in Germany. And this company got the gold medal for the Allgeier C-Dry food type contest disc dryer. And today I will talk to Mr. Matthias Trojowski. He's the Management Research and Development Process Manager. And yeah, I think it is, okay. Mr. Wettering is auch da. This is Marcel Wettering, the Product Manager of C-Dry, and Thomas Rupp, the Project Manager C-Dry Food. Hello, gentlemen. And yeah, I would like to start with my first question here. What technological progress does your solution offer compared to other well-known drying technologies?
Yes, thank you first, and hello to everybody. I'm very much pleased to answer your question. And of course, I want to thank you very much for the great honor by this award to us. Our C-Dry contact disc dryer was presented first time at the ACHEMA exhibition in Frankfurt in 2018 already. And meanwhile, it is well referenced by numerous plants in the chemical industry, in the ceramic industry, and in the environmental and recycling industry. Dry powders are produced from liquids and from liquid products by very efficient drying of the liquid at the hot surfaces of a package of rotating discs, just as you can see it in my background, by the way. The biggest advantages of the C-Dry are the very small footprint due to the compact design of the disc assembly, and due to the unique design of the disc, the heat transfer and the drying process is very efficient, and the steam consumption is low. But what is new now? The greatest challenge and the main progress of our actual development project was to make the dryer in complete compliance with the European Hygienic Design Guidelines and with the FDA rules, including easy and quick cleaning in place devices and procedures. The C-Dry is therefore available now, from now on, for drying of very many liquid food products, such as milk, yeast suspensions, gelatin, alginate, etc. So production of very special products with individual features becomes possible.
Promising in the food area, and maybe you can explain a little bit more about what new possibilities does your innovation open up in the production of food?
Yes, my name is Thomas Rupp. Hello to all. For the food industry, the C-Dry technology offers new possibilities in terms of product development and product customization. For example, when trying milk with the C-Dry, there is a possibility of a controlled partial caramelization and an increase in free fat content, which gives the dried milk powder a distinctive taste compared to milk powder conventionally produced by spray drying. The intensity of this caramel taste and the free fat content can be influenced by the process parameters. We have done detailed scientific work in cooperation with university partners and partners from the milk industry to investigate the influence of the process parameters on the powder properties. If you are interested, we are happy to share all of our results with you. Just feel free to contact us afterwards. Additionally, the compact scraping knives are self-adjusting and work with very little contact pressure, which ensures a long life of the knives. The process chamber is completely constructed in hygienic design according to the European Hygienic Engineering and Design Guidelines and the FDA regulations. There are a lot of expansions available, like a cleaning in place system for the pipes and the process chamber. And there's also an option to supply conditioned air for the vapor discharge.
Thank you so much for the explanation, also for your offer to provide more information to all interested viewers here. So, yeah, I think you demonstrated quite well what are the technological benefits, but we always talk also about economics, and are there also economic benefits that result from the application of your solution in terms of plant technology?
Yes, of course. So there are a lot of interesting points, and I just want to mention the most important things. So I think the greatest economic benefit of the C-Dry technology is the advantage of energy efficiency. If we compare the C-Dry to other drying processes, for example, convective systems, the contact drying of our C-Dry has a significantly lower amount of heat loss due to a well-controlled and adjusted exhaust air volume. And the exhaust air itself, it has only a low temperature, and it's only used to remove the vapor out of our system. So in other processes, we don't use the gas stream for the intake of the thermal energy into the drying process. And this means that the costs for the upstream and downstream equipment, such as vans and hot gas generators, filters, or scrubbers, those costs could be reduced or completely avoided. And additionally to that, the compact design of the whole system and the optimized positioning of the optional cleaning nozzles inside our processing chamber lead to a very short cleaning time. And this also reduces the need of washing water and cleaning additives as well. Hereby the wastewater volume, which is a result of the necessary cleaning step, will be minimized. And last but not least, due to the very good design and concept, the C-Dry food allows a particularly fast changeover to other products. That's giving the user a special flexibility for an individual production of different products with only one machine. So I think this were the most important points for the economic benefits of our system.
And these points already sound so convincing. So yeah, I would like to congratulate you once again for your lovely presentation here. Yeah, and I think we will be happy to, and you will be happy to answer all the viewers' questions in case there are some left. Thank you so much, gentlemen. Have a good day. Thank you.
Bye. Thank you.
Thank you. So And we have already reached the end of this presentation. I think you saw like impressive technological innovations in all kinds of the food sector. And it is our wish to congratulate again all the gold and silver medal winners. I think it's always a pleasure and really, really impressive to see what is possible and what can be done in this field. So thank you very much again. All the best to you and hope to see you soon again. Thank you very much.
Technology opens up new horizons for the food industry. Technical innovations help to optimize production processes, increase efficiency, and improve food safety. DLG offers a network for experts in food technology and innovation. Its aim is to help producers provide high-quality food for a growing worldwide population more efficiently, more sustainably. The International Food Tech Award is the focal point of these initiatives. The award has been recognizing groundbreaking developments in innovation, sustainability and efficiency in the food tech sector since 1994. An international jury of experts from 7 countries has selected the most innovative concepts in the most important areas of food production. Today, we are proud to present the winners of the International Food Tech Award